CISS226, Introduction to Java. I'm not going to spend too much time touring Canvas. I assume you all had Canvas before, and many of you probably have had me in a class before. So I tend to structure all my classes the same way. So I will talk about what is different about this class as a blended class, and we'll go from there and we'll get right into the content of this course. The syllabus is cleverly listed. The syllabus tab. You can take a look at that. Give an idea of what we're covering. The modules is where most of the work is. There's a general course information module, and there is a week 1 module. And every week there will be a module. Your assignments and the videos for this class will be posted in the appropriate week's module. Now, as you may have noticed, this class is listed as a blended class. What does that mean? It means it's sort of a hybrid between an in-person class and an online class. All right, what that means is on Mondays, there's a lecture in this classroom, BU 103, that goes from 1 to 2 p.m. And immediately following, there's a lab session in BU 210 from 2 to 3. You can watch that lecture one of 3 different ways. You can either show up in class as you did, some of you did. You can watch synchronously, that is while it's going on, which is what we have a student here that is doing that currently. And the third option is you can watch a recording that I post of the lecture after the lecture is finished. All right. It usually will be up within a few hours after the end of class. So don't necessarily expect it, immediately after the class finishes, but, certainly by early evening. If the class goes from 1 to 2, by early evening, you can expect the lecture to be posted. And if not, by all means ask. And it will be posted to whatever week's module it is. So this lecture will be posted to the week's 1 module. All right, so you can watch it in person, synchronously via WebEx, or you can watch the video asynchronously at your leisure. And the videos are all posted to YouTube. So you'll be able to get to the lecture that way. Now, we only have lectures on Monday, all right? The rest of the time, the blended part of this class relates to the fact that the rest will be taken care of through online resources and online references, in addition with you contacting me to discuss any difficulties you have, all right? Don't think of it as bothering me. All right, if we can meet online or even in person during this class time if there's difficulties you're having with the material. All right, and I can make arrangements to meet other times as well. So just let me know if you're running into difficulties, and I'll be glad to work with you to get those difficulties straightened out. Again, typically I meet with people online, but if you would prefer or if circumstances keep you from being able to meet online, we can certainly meet in person to discuss issues that you have. All right. Any questions about that? That's why, in a way, I don't take attendance, because I don't know who is watching when. I mean, I can see, a couple people are here and a person's online, but the other people I would assume will watch the class at a later time. Right? Okay. I think that's all as far as this stuff goes. You're responsible, again, take a look at what to do this week. That'll kind of have a list of things. Here are some of the supplementary resources I talked about to review. Read the syllabus, review the materials and course information, review these resources. And one of the things that you are to do is to set up your computer to run Java. All right? There's information about that, how to set up your computer to run these classes. There is a page in the textbook to do it. You can also Google installing Java. And I think, is this? Yeah. It's a link to the Java download page along with instructions and so forth. That should be job one for you this week, making sure that you got Java installed and running. How do you know if you've done that correctly? You'll know that you've done it correctly if you're able to take in the Hello World application that I am going to talk about today and run it on your machine. That's how you know that you have everything set up. So that should be job one for you. When you get that, when you're sure you have that working, then take a look at completing lab one, which is really just sort of an extension of the Hello World app. Okay? Let's talk a little bit about the Java environment. You start out, you have what's called your source code. And those are going to be in files that end with a .java extension. Okay? Files that end in a .java extension. Those files get compiled. Compiling the program creates what is called bytecode. All right? That bytecode can be run using the Java runtime engine, which sets up a Java virtual machine to run your program. One of the chief advantages of Java throughout the years is the fact that it is cross-platform. Especially back in the past, there tended to be the Microsoft world and the everyone else world. And Java was a leader in the everyone else world. All right? And this process of compiling to bytecode is one of the things that makes it cross-platform. Because this program is platform specific. All right, platform specific. In other words, there's a Windows Java runtime engine. There's a Mac Java runtime engine. There'd be a Linux Java runtime engine, and so on. There will also be the code that allows you to compile, and that's called a JDK. Jdk Java Development Kit. And that also exists for platforms. So you will look up your platform, whether you have a Mac or you have a Windows machine or whatever, to compile it. They are responsible for the compilation process. Now, one good thing is if you download the JDK, you get the JRE with it for free. All right. So you don't have to worry about when you're doing an installation of installing the JDK and the JRE. If you just install the JDK, you will have Java installed and you'll have the runtime engine. All right. Now, at least in theory, this bytecode that you compile on whatever machine that you've compiled it upon should be able to be taken to any other machine that has a JRE and run on that machine. So in other words, you can compile a program in the Windows environment and run it on a Mac. as long as the Mac has a compatible JRE installed. All right. And this bytecode is what gives the interoperability, the ability to run things cross-platform. In the old days, things were compiled to machine language. And machine language, as its name implied, was different depending on the particular machine that you were using. All right. Therefore, you could not take Windows machine code and run it on a Mac, right? And vice versa. But instead, Java doesn't produce directly machine code. It produces this bytecode, which gets executed by the JRE. All right. These are just some key terms that you should know. Source files always end in a .java. Bytecode is going to end in a .class extension. We're going to talk about classes a lot in this course. Know that all your Java code is going to appear within one class or another. All right, and we'll talk more about exactly what a class is and what it contains and how you use them. But just know that every piece of code that you write in Java is going to be in one class or another. All right, so let's start our exploration by looking at the Hello World app. This is sort of the traditional app that programmers develop to introduce themselves to the language. So I'm going to this page, and I'm going to copy the code. Here's the code. I'm going to copy it. I'm going to open up a text editor. All right. Now, there's a lot of editors you can use. You can use, we'll talk about some of them now, and some of the IDEs we'll talk about later. You could create Java programs using just plain old Notepad if you wanted to. You could create them using Notepad++, which are installed on the machines here. What I have become sort of a convert to is creating my code in Visual Studio Code. All right, Visual Studio Code is not the full-blown version of Visual Studio. It's like a text editor, but it has a lot of nice features in there, including IntelliSense and so on. So I'm going to start up Visual Studio Code. And I'm going to click New. And I'm going to paste in here my Java code. Or I can click here and select the language first. Let's do that. And I can paste that. Sure do want to hide that. Hide editor. Here we have it. And this is called the Hello World app class, implements an application that simply prints Hello World to standard output. All right, what I'm going to do is I'm going to go through the process. Before we look at what this code means, I'm going to go through the process of showing you how you create, compile, and run a Java program. All right, I'm going to go and I'm going to save this in a folder on the desktop. Let me go to the desktop. I'm going to create a new folder called Java. And I'm going to save my file in there. Now, when I save it, whatever the name of the class is, I'm going to save it in that file, that class name, .java. So this one is Hello World App. I'm going to save it in a file called hello world app.java. These are important conventions to follow. All right. You should follow them, and it should be case sensitive. I know Windows doesn't always care about case sensitivity, but if you run in other environments, it will. So it should match the case as well. We'll talk about this more when we get more classes than this one, but if you have more than one class, they should each get their own .java file. So if I had class 2, class 3, class 4, I'd have a class 2.java, class 3.java, class 4.java. That is true with only a couple of little exceptions that we'll talk about later on towards the end of class. So let me go and save this. I'm going to save it inside my Java folder. And I'm going to call it hello world app.java. Because I said initially this is a Java code, it knows to store it in a .java file. So I saved it. So now I have this file out here, and I want to run it. Well, I have to compile it first and create this bytecode, and then I can run it. I'm going to actually go to the command line. Now, how many of you have had operating system CISS226? Have any of you ever done anything with the command line before? Okay. Good. We're going to go to the command line. And I'm going to get into the folder that my source code is in. So I'm going to go over to CD to the desktop, CD to Java. Do a directory listing. There you see is my .java file. I'm now going to compile it. And you compile your Java code by saying Java, the name of the source file that you want to compile. So I want to compile hello world app.java. So I type in Java hello world app.java. That was a mistake. Even though it worked, that was a mistake because that didn't show me what I wanted to show. I think it's interesting. What I should have typed was Java C. One nice thing, by the way, is you can use these arrow keys to pull up old commands, so you don't have to type the whole thing in. So for example, use the up and down arrow key. The up key takes you back through history. The down takes you forward through history. So I'm going to say Java C hello world app.java. All right. It didn't tell me anything, so it didn't give me any errors. This is one case of no news being good news. If I look at the directory listing now I'll see I have, in addition to the hello world app.java, I now have the Java world or hello world app class, which is the bytecode. Now, bytecode is not human readable. So if I were to look at this file, it would be unreadable, undecipherable for the most part to the human eye. To run it, now I type in hello world app, and it tells me hello world. So we follow that model that I showed you a minute ago. We created our source file, our .java file. We compiled it to produce the bytecode file that ends in .class, and then we used our JRE to run that and to get the results. Now, let's look at the source code itself and sort of dissect it, all right, and see what all is in it. First thing that we have are comments. You can do a block of comments by doing a /* and then end the comments by a */. Now, this is one nice thing that Visual Studio Code does for you, is that it color codes the fact that these are comments. If you were to do this in Notepad, just plain Notepad, you could do it, but it wouldn't color code it for you. If I have a block of comments, for example, it's usually a good idea at the top of a class to define what that class is for. Maybe define who created that class. Maybe even define some of the updates to the class. Give it a version number that an update, the original version is version 1.0. In version 1.1, I corrected the spelling of hello, for example, and so on down the line. But the /* indicates a block of comments. I can also put comments in a single line like this. I put in line 6 a single line comment. You have to have one class with a main method. Now, keep in mind, when I make sweeping statements like this, you have to, or always, or anything like that, know that there might be some minor exceptions to it. All right. It's just easier for me to say you have to have a class with a main than to say, well, you have to have a class with a main unless blah, 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 blah is true. So it's just easier, at least when we're starting out, for me to say, hey, you have to have one class with a main. The first bunch of projects that you're going to run, you have to have a class that has a main method in it. In fact, I think all of them in this course, you have to have at least in every application or mini application, right? You have to have one class that has a main method. The other thing you can do is You can put slash slash anywhere on the line, then the rest of the line becomes a comment. Something like that. Okay, so that's comments. It's a good idea to comment your code to let someone using this class understand just exactly what the class's purpose is. Likewise, comment methods and attributes and so on. One thing that's not easy to tell, not easy to determine in this class, but you sort of have to take my word for it, is that when you develop classes, it's not like you develop those classes and then you're done with them. All right? Someone may use your classes. All right? You may create, for example, a customer class that has all the business logic concerning what happens with a customer at your organization. How does this customer charge shipping? Does this customer receive any special discounts? Does this customer have any special deals as far as the price goes? Things like that. You may create a custom class or a class for a customer, and then other people are going to use that as a building block for their application. So it's not like you create your code and then you're over and done with it, right? Each of these classes becomes a building block that other people can use in their applications, all right? So it's good to have comments in your code because chances are you're not going to be the only one that's going to touch this code, all right? In addition, even you, 6 months down the road, if you don't comment your code completely, might forgot why you did something a certain way. So it's a good idea to put things in it. To this day, I run into things on my to-do list. I have no idea what that's supposed to do. I wonder, like, am I late paying a bill? Did I forget to call someone I was supposed to call? Oh well, That's why putting in good explanations in comments is a good thing to do within your Java program. Okay, so that's it about comments. You don't have to have comments, but it's a good idea. Now, I mentioned all our Java code is going to appear in a class. All right? And that's what this defines. We have the word class, we have the name of our class, and then we have a brace or curly bracket that indicates the beginning and end of the class. So everything between those braces is the body of the class. Braces have to be nested properly. We'll see that in a minute because we're going to look next at one of our methods. And that method is the main method. Now remember, you have to have at least one main method or one class with a main method within your application. And it starts out like this. Public static void main, and then parentheses as optional arguments, string, space, args. I'm going to try to explain what this means. If that's not clear at the moment, it's okay. Just remember it has to be this. All right, it has to say public static void main, and then the arguments. Public indicates that other classes or the command line can call this method. Methods can be either public, private, or protected. We'll only worry about public and private right now. Public means that the command line and other classes can call the method. Most of our methods are going to be public. There might be an occasion to have a private where you don't want other classes to call that method. And when we get into inheritance, we'll look at protected. Now, as a safe rule of thumb, like for the first few assignments, you're probably going to want to make all your methods public so that other classes could call them. Static, we're not going to get into right now. Just memorize after public, you got the word static. We'll talk about this later on. Void indicates what kind of value the function returns. Now, void indicates that this function doesn't return anything. Some functions return things, some functions don't return things. You might have, for example, calculate the area of a square function, where you pass in the size of the length of one of the sides of a square. And the function does the math and returns the results. So maybe it will return an integer. You give it an integer and it returns a value of an integer. All right. In which case you'd say public int to indicate it returns an integer. Or if it returns a string, public string. If it returns a Boolean, public Boolean. All right. But in our case, this main function doesn't return anything. Therefore, we say void. We then have the name of the function. And remember, within Java, the case matters. And we'll see examples of that in a minute here. All right. But you need one main method, and that main method begins with a lowercase m. Typically, we use what's called camel cases for methods, which means the first letter of the method is lowercase. Subsequent word is uppercase. So if I had a method called main example 2, which would be a horrible name for a method, but it would look like this. M in main is lowercase, example is uppercase, 2 is uppercase. But in our case, in our instance, main needs to be lowercase. String is actually, string with the square brackets, args, actually indicates that we can pass arguments to this. So when I run Java hello world, I could actually give a list of arguments, and those get put into an array, and you can use those. We're not ever going to use that, but you should at least know what that means in this declaration. So if I was going to read this and interpret this, I have a method. It's public. It means anyone can call it. By anyone, I mean any other Java program. Static has to be there in the case of the main. We're not talking about what that is. If you studied other programming languages, it probably means about the same thing as static in those languages. Void means it doesn't return anything. Main is the name of the function, which again, we have to have at least one main, so you're going to be a function named main somewhere. And then this is the arguments, the optional arguments that we can pass to this function when we run it. All right. And then we have the braces that indicate the beginning and end function. Right. These are nested so that the outer ones represent the beginning and end of the class. The inner ones represent the beginning and end of the function. Now we're actually printing out the data. And if you're going to like see the official description of this, system out println sends to the standard output something. Now, in most cases, unless we've changed it, the standard output is the screen. Okay. So system.out.println is going to send to the screen something. And what we're sending to the screen is going to be enclosed in quotes. It's a string that says hello world. And therefore, when I run it, I get this. Any questions? Yes.
On when you typed, you're trying to get to class in the directory.
Right.
Did you type that Java C to the C with that to get to the class?
No, the Java C actually, and again, forget what the first pass I tried. Java C means Java compile. And then I have the name of the class. And then Java with the name of the class. And again, when you compile, you have to say the name of the file. So class name .java. When we go to run it, we don't have to specify .class. We just say Java hello world app, and it knows to execute the .class file. All right, let's play my favorite game. Let's mess things up and see what happens. All right. Now, I almost wish I could like real quick turn off the projector and then turn it back on again, but that would possibly damage the bulb of turning it on and off. So I'm going to ask you to close your eyes. All right. And if you don't, if you cheat, you're not going to win anything, so it doesn't matter to me. All right. So close your eyes for a second. All right, you can open them now. I'm going to compile and run it. Well, let me put it this way. I'm going to try to compile it and run it. All right. Now, this is a case of maybe you see this quickly, maybe not, but the error, the description you get for the error isn't necessarily self-explanatory. All right. It tells me that this line 8, has a problem and it cannot find symbol. System.out.println. Tell me it doesn't know what that is. It doesn't know a method named ln. Does it think it's a method? Can't find it. Well, because there's parentheses after it. Right? So it thinks it must be a method because there's parentheses after it. They can't find a method called that in the variable out. So in the variable out, there's no method called println. All right. System.out is a built-in sort of the Java framework class. And it's telling me that class, system out, doesn't have println method. Does anyone see what's wrong with it? Just worked a minute ago. What did I mess up? Well, at least I know you're honest and actually closed your eyes. The difference is this, that the L in println should be a lowercase l, right? Now, this is where, like, you know, computers can do all these great things, you know. I don't know if any of you saw those artificial intelligence generators, like they were big on social media, where you can go to a page and you can type in teddy bears playing tennis, and artificial intelligence will create an image that has that in there. And some of them are kind of funny because they're a little off, because it's not a human doing it, it's artificial intelligence. But you can create all these great things with computers, and yet it can't tell you more directly, hey, you spelled println wrong, you used a capital L, right? So if it tells you that it can't find the symbol, and you think, well, of course it can find the symbol, I know that's what it's named, consider the case, because the case is always going to be a problem. Likewise, if I did this and made system out with a lowercase s, package system doesn't exist. Again, well, yes, it does, but it's named with an uppercase. We could do that all over the place, right? Here's a good one. What if I make main uppercase? Filed okay, all right, but we can't execute it because there's no main method defined with a capital, with a lowercase m. We have a main method that's defined with a capital M. So it's not going to give you an easy to understand message. You have to decipher some of them, and that's where I come in to assist you. I mean, don't feel bad if you have a problem and you can't figure out what an error message means. Send me the code, and I'll take a look at it, and I'll be able to help you interpret it. I do want you to sort of follow like the list of the most common things, though, and certainly high on the list of the most common things are capitalization or outright spelling. If I spelled that wrong, it would give me an error. Another thing that comes into problems is if you do not have the proper number of braces. And this isn't a very descriptive error. It says, reached end of file while parsing. All right. Again, what does that mean? What that means is it was expecting to get to something and it hit the end of the file before it got what it was expecting. In this case, there were 2 left braces, so it was expecting to find 2 right braces. And when it reached the end of the file and it was still expecting another right brace, it gave me error. Really omitting any of these if I don't say avoid be a problem. I've been defined the return type for it. Okay, that was a pretty descriptive error message for once. If I define a function and don't describe what arguments it takes, it will also give us an error. All right. So the first thing to do is, I assume you all are going to work on a machine outside of school. Yeah, I mean, you can work on the machines here as well, but I'm assuming you're also going to do some work outside of class on your own machine. First thing to do is make sure you have Java installed, both the developer's kit and the runtime. Right? How can you tell that you have it installed correctly? By going in, opening up this, and copying and running this source code. Creating a class Hello World app. Now, your assignment requires a little bit more than doing the Hello World, though. It involves randomizing. And I actually have a sample code that's very similar to what you need to do. Right? It's my version of the Hello World. And I'm going to download it. I'm going to save it in Java. And when I try to compile it, I actually get an error. Why do I get an error? Because there's a mismatch between the name of the file, which is hello world -1, and the name of the class, which is simply hello world. Well, that's a hello world app. Do this one in WordPad then, or Notepad rather. One thing I'd have to do is I'd have to rename this to match the name of the class. The name of the class is Hello World. I'd have to change the Java file to hello world.java. I have changed it to say hello and give one of 4 random names, me and my siblings. So if you take a look at this and some of the other resources that I posted, it will show you how to generate a random number. What this is going to do is it's going to generate a random number between 0 and 3. All right, 0 and 4, but non-inclusive on the 4 side. So we'll go up from 0 up to 3. And it will select that person from the name array list to display. So this is my special version of Hello World, and it tells me each time I run it, it'll give me a different name. Well, not each time I run it, but each time I run it has the potential of giving me a different name each time. So what you have to do for your assignment is take a little Mad Lib, fill in the blanks randomly. It's lab 1. All you need to be able to do is create an array, create some random number, or create several arrays, create several random numbers, and then do a system out print ln to output and say something like, if you used Mary had a little lamb, you could substitute a random word for Mary, lamb, and fleece. Questions about anything I've covered in class today? All right. Do remember that we do not have class on Wednesdays. This is part of the blended deal. But you can use that time to work on your stuff and contact me if you have difficulty, and we can arrange a time either on that Wednesday or some other time to go over your questions. That's all I had for today. Our lab is up in BU 210. Is anyone going to lab today? You're going to? Okay, that's cool. Well, the labs are that days that I'm here and have lecture, I will be in lab. All right. So the days that we don't have lecture, then you work on them on your own machine. All right. Okay, we'll see you up in lab.